Ready to take your SQL skills to the next level? In this video, we're going to be covering 12 advanced SQL querying concepts in just 20 minutes. We're going to start our demo with a simple select statement, and step by step, we'll work our way up to a final query that contains a join, a union, a CTE, multiple window functions, and much more. Now let's get right to it. Let's start by taking a look at the table we're going to be working with, the sales table. So if I run this line of code here, you can see we have all these dates and the number of sales on each date, and there are two dates that are missing, the 3rd and the 6th. So what we're going to do is add in those two dates and include sales estimates for those two dates as well. So let's take a look at what we want our final results to look like. You can see here we have the 3rd and the 6th, and then we have sales estimates for those two dates as well. And these sales estimates are taking the average of the prior and next day's sales. Now to get to this final output, we're going to review 12 different advanced SQL concepts, starting with union and union all. So the first thing we're going to do is generate a series of dates. So if you look at our original sales table, you can see here we have these missing dates, but we're going to generate a series of dates without missing values. So to do this, I'm going to start with a select statement and list the first date that I want to see. And now if I just run this query here, you can see I've generated this first date. Now let's add on another date using a union. I'm going to do a select, and then I'm going to list the next date. And now if I run this, you can see I have these two dates here. And now I can continue doing this for all the dates, but I'm not going to list them all here because that's going to take a really long time. So let's just start with these three here. You can see in this case, if I run this query, I get these three dates here that I've generated using a union. Because what a union does is stack the outputs of all these select statements on top of one another. Now in this case, we don't have a clean column name here, so in my first select statement, I'm going to name this column DT. And now if I run this, you can see all my dates. So that's how a union works. Now let's compare that with a union all. So what I'm going to do is actually change this last date to the second. And if I run this, you can see here, even though I'm stacking these three values, only two are in my output. And the reason for that is because with a union, if you have repeated values, they're going to be removed because a union will stack all the values and remove any duplicate values. Now that's different with a union all. So now if I change these values to union all instead, and I run this query one more time, you can see that my duplicate value does not get removed. Instead, these three values that I listed here get stacked exactly as is. So to quickly summarize this, union and union all both allow us to stack our select statements. The difference is with union, the duplicate values will be removed, whereas with union all, the duplicate values will stay here in the output. Now with this, let's move on to our next step. What we're going to do here is combine our series of dates with our original sales table. And we're going to introduce these three concepts here. So to get started, I'm going to include a much longer query that includes the dates from the 1st all the way to the 7th. So now if I run this query, you can see here I've generated this series of dates. Now what I want to do is combine this output with our original sales table up here. And the reason I want to do that is because I want to get information from both outputs. So in this case with our sales table, I want to extract all these num sales values, and then down here with this huge query here, I want to include all these date values here. So the first thing we're going to do is turn this here into a subquery. And what that will allow us to do is take this output here and give it a name so we can reference this entire output here like we would reference a table. So to do that, I'm going to add parentheses around this, and then I'm going to name this as my subquery. So now going forward within this query, this entire output here is going to be called SQ. And I can treat this whole thing as if it were another table. And now I'm going to write a select statement around that. So I'm going to say select all from this table here. And if I run that, you can see I get this output. Okay, so that's your basic introduction to a subquery. There's going to be another example later on in this demo as well, so you'll get another idea of what subqueries can do. Now at this point, we have all these dates. We just want to bring in those number of sales. So again, if we look back up here at our sales table, you can see these are the num sales we want. So to combine this with our generated dates, I'm going to say select all from subquery, and then I'm going to do a left join on the sales table. And then I have to specify what column these two outputs have in common. And in this case, both of them have a date column. So you can see in this subquery here, there's this date column. And then down here in the sales table, there's this date column. So I'm going to say from the subquery, look at the date column, and that should be equal to from the sales table, again, look at the date column. Now if I run that, you can see we've joined two outputs here. This here is from my subquery, which is my left table, and then I've joined that with my sales table, which is my right table. And the reason you see these null values here is because within the sales table, we're missing information for the 3rd and the 6th. Now, because we have these repeated columns here, I'm going to specify only this column here and this column here for our output. So up here, I'm going to say, instead of select everything, I'm going to say from our subquery here, I want this date column. And then down here from our sales table, I want the num sales. So I'm going to say from sales, I want num sales. And if I run this, you can see in my output, I just get these 2 columns that I've specified up here, our subquery and our sales table. Now in this case, we've done a left join. And what the left join allows us to do is keep all the rows from our left table or from our subquery. And then any rows that don't exist in the sales table or our right table will be filled in with null values. So that's how a left join works. We can also change this to an inner join. And if I run this, you'll see my output doesn't include the 3rd and the 6th. And the reason is because with an inner join, the output will only return rows where the date exists in both the subquery here and the sales table here. And if you remember our sales table, that didn't include the 3rd and the 6th. But in this case, we want to see the 3rd and the 6th. So I'm going to update this to a left join again. And now we have the 3rd and the 6th, and we have these null values here that we're going to fill in a later step. But at this point, we have gone through 3 more concepts. This subquery here, which allows us to reference this output as SQ, and then we can write a query around that as if SQ were another table. And then we also talked about 2 different types of joins. The left join allowed us to keep all the rows from our left table, and then the inner join only returned rows that existed in both tables. Now let's move on to the next step, which is to rewrite our subquery as a CTE. So in this case up here, we had a subquery, but there's a more modern concept called a CTE, or a common table expression. And what we can do is rewrite this query up here that uses a subquery to use a CTE instead. Once you see what that looks like, I'll talk about the advantages of using a CTE versus a subquery. So let's start by just copying this entire query here down into this section. And the way that CTEs work is instead of writing your subquery within your query, you write your subquery at the very top of your query. So what I'm going to do is take all this, cut it, and paste it at the very top here. And now the syntax for a CTE is a little bit different. So instead of all this here as SQ, I'm going to do a with SQ as, and then delete this whole thing down here. And now I'm just going to add some tabs here to make this look nicer. Now what we've done here is identical to what we've done up here. The only difference is the organization. So in this case, we did a select from, and then this was our subquery, and we called it as SQ, and then we did our join. And then down here, the difference is that we define SQ up front. And instead of doing all this as SQ, we're doing with SQ as, and then all this here. Now, just to show you what this looks like before we move into our join step, I'm just going to do a select all from SQ here. And if I run all this, you can see our output looks exactly the same as before. We're treating this entire section here as SQ, and now I can do a select all from SQ. Now let's delete that and continue with our original query. Remember, this was our select statement from before. So if I just scroll up here one more time, you can see before this whole thing was SQ, and then we selected these 2 columns from SQ and we did a left join. Now we're just switching up the steps a bit with the CTE. We're saying this here's SQ. Now again, we're going to look at these 2 columns. And then for this from step, we're going to say we want to get these 2 columns from SQ, which is our query here. And we're doing a left join on sales again, so we can get all the dates here and their corresponding sales. And if I run this, you can see we get the exact same outputs as we did in the previous step. So at this point, you might be wondering, why would I use a CTE instead of a subquery? And the main reason is because of organization. Both subqueries and CTEs allow you to write select statements around select statements. But with a CTE, you can state everything up front at the very top and then cleanly query it down at the bottom. So up here with this subquery, you can see in this case, this subquery sits in between our greater select statement, but then down here, our subquery or our CTE is at the very top here, and then down here we have this nice concise select statement. And this makes an even bigger difference once you're writing multiple subqueries or multiple CTEs. With subqueries, you would have to write all these select statements within your query, but with CTEs, you can list everything at the very top, CTE1, CTE2, and so on, and then write a simple select statement at the bottom. Now, before we move on, I'm just going to rename this. Instead of calling it a subquery, I'm going to call it a CTE because that's what it is. And then I'm going to update all these values down here as well. And now if I run this, you can see I have the exact same output down here. I've just cleaned up my query a bit. Okay, let's move on to the next step, which is rewriting our current CTE as a recursive CTE. Now, a recursive CTE is a very specific type of CTE that allows you to use recursion. Now, recursive CTEs are much less commonly used than CTEs, so you don't have to memorize the syntax in the next step, but just be aware that this concept exists. So what we're going to do is take this entire query up here and copy it down here. Now, in this step, what we're going to be updating is this section right here. You can see here that we're doing the same thing again and again. We have the first, union all the second, union all the third, and so on. And if we had to generate a series of 100 dates, we wouldn't want to write this 100 times. That's really inefficient. So instead what we can do is, because we're repeating the same thing again and again, we can write a recursive CTE. So to do that, the first thing I have to do here is add the recursive keyword. And now down here, I'm going to update my query. So I'm going to start by adding some indentation here. So currently we're doing all these union alls. What I'm going to do is actually delete all these down here, because what I'm doing is just the same 2 lines again and again. Union all select, union all select. So if I delete these here, what I can do is summarize all that with just these 2 lines here. So in this case, I'm going to do a union all, but instead of selecting this hard-coded date, I'm going to make this more general. I'm going to say, take the current date, which is DT, and then I'm going to add 1 day to that. So currently I'm using MySQL, and within MySQL, the date expression for 1 day is interval 1 day. This might look slightly different in your specific SQL editor, but the general concept is the same. We're just adding 1 day here. And now in this case, because we're doing a select DT, we have to specify where DT is coming from. And you can see in this case, DT is coming from the common table expression. So I'm going to do a from CTE. So at this point, we're starting with the first, and then we're adding 1 day at a time. And if I just do this, this is going to generate a lot of dates. So we need to stop this at some point. And in our case, our dates only go up to the 7th. So I'm going to do where DT is less than the 7th. And what that will allow us to do is keep on adding 1 day at a time until we hit the 7th. Now we're almost done with this recursive CTE here, but I'm going to add one more function called cast. And what cast will allow me to do is turn a string value into a date value for the duration of this query. So at this point, this value right here is just a string. It's in quotes, so SQL is looking at it as if it were just a text value. But this here is more than just a text value. It's actually a date value, and we want to do calculations on it. We want to add 1 day to this date value. So to turn this into a true date value, we're going to add on a cast function here. And I'm going to cast this string value as date. And once we do that, we're able to do date calculations, such as add 1 day to this value here. And I'm also going to do this cast down here to interpret this as a date value. Now with that, we are done with our recursive CTE up here. And just to show you what the output's going to look like, I'm going to do a select all from CTE. And if I run that, you can see that this CTE here generated all these values. And this code here is a lot more succinct than all this code up here, but they do the exact same thing. They generate a series of dates from the 1st to the 7th. But down here, we're able to do it in a systematic way instead of hard coding each date value. And we were able to do this using a recursive CTE, which is a CTE that references itself. So we've called the CTE CTE, and then you can see within the CTE, we're referencing CTE. So that's what makes this recursive. Again, this is much less commonly used than all the other things I'm covering within this demo. The code will also look slightly different for each flavor of SQL, so you don't have to memorize the syntax, just know that this is possible within SQL. Now for this section, we covered recursive CTEs, and we also talked about date expressions and date functions. So this here is called a date expression. That's allowing us to do a date calculation. And we've also used a date function here called cast. And it's a function because of these parentheses here, and that allowed us to turn a string value into a date value so that we could actually do this calculation down here. Now with that, I'm going to delete this simple select statement and run this query with our original select statement. And if I run this, you can see again, I get the exact same results with all of our generated dates and the 2 null values here. And now what we're going to do next is fill in those null values. So I'm going to copy this query from up here, down here. And what I'm going to do is add on another column with a sales estimate that fills in these null values here. So to do this, I'm going to use a null function called COALESCE. This is a really popular null function, and basically what it does is it searches a column, and then wherever it sees a null value, it's going to fill it in with some other value. So in this case, let's specify that we want to look at this num sales column. So we specifically want to look at this column here, and wherever there's a null value, Let's say we want to fill it in with a 0. And now I'm going to save this column as my sales estimate. Now if I run this, you can see we have this new column here, and wherever there's a null, we filled it in with a 0. And we were able to do that using this null function called COALESCE. Now this here was a simple situation of COALESCE. Let's do a more complex situation. So let's copy this entire column here, and we're going to call this sales estimate 2. Let's say instead of making these null values 0, we want to fill these in with the average of this num sales column. This is a popular data science technique called imputation, and a common way to impute null values is to fill in null values with the average of the column. So what I'm going to do here is include a subquery instead. I'm going to calculate the average of the num sales column. So I'm going to say select average of num sales from this sales table. And now if I run that, you can see here, instead of a 0, these values have been filled in to be 77.8, which is the average of all these sales here. Now to clean this up just a little bit more, I'm going to add a numeric function around this called round, and I'm going to round this output here to 1 decimal place. And now if I run this, you can see this output here is a lot cleaner, and we were able to generate this output using 2 types of functions. First, a null function called COALESCE, which allows us to fill in null values, and then also a numeric function called round to reduce the number of decimal places here. Now with that, we're going to move to the last 2 sections here, which introduce the last concept of this demo, which is window functions. Now before I incorporate window functions into this query here, I'm just going to introduce what they are real quick. And to do this, we're going to look at our original sales table again. So here is our original sales table, and instead of doing a star, I'm just going to select the 2 columns here. So what we're going to do now is add on a column that uses a window function. And what this window function allows us to do is generate a column of values across a window of data. Now you can think of a window of data as certain rows in your data. The easiest window to understand is just all the rows of data in your data set. We're going to start with a really common window function called row number. And what this will allow us to do is generate a row number value for each row of data in this output. Now, when you're writing a window function, you first have to specify your function, and then you have to specify what your window is. And you can do that using the over keyword. And because in this case, we're just going to be looking at all the rows of data, I'm just going to keep this simple and do over with nothing in the parentheses. And now I'm going to save this output as row num. So now if I run this query, now you can see here with my row number window function, I've been able to generate this column, which adds a row number value to each row of my data. And in this case, because I didn't specify anything in this over section here, the window it's looking at is all my rows of data. So it's going to create these row numbers for all my rows of data. So now at this point, we've covered the row number window function. Let's use a few other window functions as well. So instead of row number, the one I'm going to use next is called lag. And then the third one I'm going to use is called lead. And what lag and lead will allow me to do is return the prior row's value as well as the next row's value. Let's say we're looking at the num sales column and I want to return the prior row's number of sales. In that case, I can do a lag of num sales. And then I'm going to paste that down in this lead section as well. So now if I run this, you can see down here in my output, by using the lag function, for every num sales value, we return the prior row's number of sales, which is 61 in this case. And then for this row, the prior row's sales is 72. So that was lag. And then for lead, we're returning the next row's number of sales. So for 61 here, the next row is 72. For 72, the next row is 84. And because we're not specifying anything in this over section here, we're making these calculations for all the rows in our data. Now, these are some simpler window function examples. If you want to see some more complex examples that use keywords like partition by or order by, you can check out my window functions video. And that will go over situations where you don't just make calculations for your entire data set, but different groups of data at a time. Now, for the time being, we're just interested in these simple window functions here. And now what we're going to do in this very last step is update our query from up here. And instead of filling in the null values with the hard-coded value or the average of each column, we're going to do something even smarter. So for the third here, we're going to take the average of these 2 values. For the 6th here, we're going to take the average of these 2 values. And now that you've been introduced to window functions, you probably have a general idea of how you would do this. You would use some combination of the lag and lead function to take the average of the prior and next row's values. And now I'm also going to update these column names here to be more specific. And now if I run that, okay, you see we have our prior row and our next row. So with that, let's create our final query. What I'm going to do is take this entire query up here, copy it down here. And if we run that one more time, you can see so far we have all our dates, our original number of sales, and then these 2 estimates here. Now what I'm going to do is create a third estimate. So I'm going to copy this down here, and then call this estimate 3. And in this case, we're going to use COALESCE again because we're going to say whenever we see a null value, fill it in with this other value. And this other value here is going to incorporate window functions. So I'm going to say when there's a null value here, take a look at the prior value, add it with the next value, and then divide that by 2 so we get the average of the two. So the prior value was the lag of num sales. And now I'm going to add to that the next value, which is the lead of num sales. And now I'm going to take all that and divide it by 2. Let's delete this comma over here. Now if I run this, you can see that my third sales estimate is a lot smarter. So for this particular null value, it's taken the average of the 2 rows around it. And then for this null value, again, it's taken the average of the 2 rows around it. And let's just add our numeric round function around this one more time, and that will round our output to the nearest integer. Now to clean up this final query, I'm going to delete some of these extra columns here so that we only have our date column and then this final sales estimate. And if I run this, you can see we get for all these dates, the sales estimates, even for these 2 missing dates here. And we were able to do that with this final query here. So hopefully by the end of this video, this query doesn't seem as intimidating and you have a general idea of how each piece works. So there you have it. In just 20 minutes, we've covered 12 advanced SQL concepts. I go through all this in a lot more depth in my course, Advanced SQL Querying, which includes dozens of assignments and a final project for you to get hands-on advanced SQL practice. If you're looking for more ways to level up your analytics skills, check out our self-paced courses, guided projects, and portfolio showcase at Maven Analytics and create your personalized learning plan for free. Thank you so much for watching, and as always, make sure to like and subscribe for more data content just like this. See you in the next one.